What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, we are going to continue improving our camera by converting it to code. So the previous episode, we started implementing the camera in code, and we got pretty far through it, but there are a few more things we have to do. Today we're going to be tackling the camera edges, basically what determines how far we can go on each side of the screen. I call them camera edges, but really they are just the boundaries for the stage. And the camera does use them to determine a few factors like how far we can go and how far it should really show. Or rather, we set it up. That way we know that our representation is correct and that our camera only goes to certain bounds. So we're going to be tackling the camera edge class today. We're going to be converting this to code. This one's a lot simpler than the camera, but once we get this converted to code, we can then use it in our camera code class, which we set up in the previous episode. And then we'll have very little left to actually do to fully convert the camera to code. So before we hop into today's episode, if you're interested in getting caught up in the entire fighting game tutorial series, I'll link you to the full playlist right here in the top right corner. You can see how we've done things from our hitboxes, our online multiplayer, and a lot of fun things like that. Alternatively, if you only care about the camera and the camera edges and converting these things to code, I'll link you to the first episode of the camera right here so you can see our starting point. And then the previous episode in the series was where we started converting it to code, so you might want to check that out as well, just so you can follow along fully with this episode. But with those things out of the way, we can go ahead and get started. Now this is a code and blueprint tutorial series, but we're going to be converting things from blueprint to code today, so we're going to be using a mix. The very first thing I want to do is make a new C++ class. Like in the previous episode, I've already done this. When you're in the engine, you can go to C++ classes, go inside your folder, go to where you want to create this. I called it base camera edge, and I put it right here. So I can right click in here and go to new C++ class. This works in Unreal Engine 4 and 5. And for me, the camera edge is just a child of actor. If we actually go to our camera edge and go to class settings, you can see the parent class, which is actor. So I want to follow this. So I can select actor right here, and then alternatively you can go to all classes and find any specific class if you have one in mind, such as actor. Go to next and name it what you want. For today's episode, I did call this base camera edge because I like to use the term base, meaning that we could derive from this in the future. Now the camera edge in particular, we probably won't need a child class of, but I can think of a few times we may, like a breakable camera edge, like a stage transition camera edge. So I just stuck with this naming convention for now. Put it at the path you want. Go ahead and create class, which I could do if this name wasn't already being used by the class I created prior to this episode. Once you do this, if you're launching through Visual Studio like I am, you may have to close or reload your environment. Sometimes it also just works nicely, and you don't have to do that, but regardless, it should create a code class for you, which I'll show you in a minute or two. First, let's go to our camera edge blueprint class once you have the editor back open, because that's what we're going to be using for reference today. So for me, it's in blueprints, functional BPs, cameras, camera edge, and this is what my class looks like. Now the hierarchy is pretty simple here, so we have the actor itself, and then it has a default scene root, which has a box collision component, and then it has a static mesh to visualize it for testing purposes. To make our lives easier today, we don't even need this default scene root. This default scene root is a component that gets created when there's nothing else here in the component list, but you may want to change some things about it like the scale, the visibility, and so on and so forth. To avoid making another component that we don't actually need, I'm going to replace the default scene root with this box collision component that we have. It's not super important that you see what I have in all my settings here, but I'll scroll through it again just in case you want to see. This is what all of mine look like. You'll have to probably slow this down or pause it to grab it. But I haven't changed anything since we initially set this up. I'm just showing you what mine looks like in case that's helpful for you. Alright, so to replace the default scene root, you have a few different methods. For me, I'm just going to drag the box collision component onto the default scene root, and here it says drop here to make box the new root. The default root will be deleted, and we can do that. That won't actually impact us in any negative way for our camera edges. And to test this, you could go ahead and play your game again and run through a few tests. So first of all, left character should be able to go all the way to the left and stop walking. Right character should be able to do the same. Those are the internal boundaries. Also have external boundaries, so if we go too far to the right, we can't go anymore, and if we go too far to the left, we can't go anymore. If you are using the 3D playstyle from the 3D fighter episodes I have, then you'll want to check your back and forward boundaries as well. I've already done this in a test on my own project. That way I know everything was working before I showed it to you guys, but feel free to test it out as well, just to make sure nothing broke. But now our blueprint is a little bit simpler, and we only have a little bit in the event graph, but we are going to convert this today as well. So at this point, we can go into our code and make sure everything is set up properly. So I'm here in Visual Studio, and if I go to my games, fighter template, source folder, fighter template folder, where I put this class, I should see it here, basecameraEdge.cpp and basecameraEdge.h. Go ahead and open both of those up. Let's start in the header file. It should look something like this when it gets generated. It might be a little bit different depending on your engine version, the actual class that you chose, if you didn't make it a pure actor, so on and so forth. But nothing here is anything that I've added. I've only changed around a few of the comments and order of the functions, which doesn't matter, just organizes it for me in a way that I like a little bit more. Then we go to the basecameraEdge.cpp, and it should look very similar to this. Again, I haven't added anything to this class yet, I just created them. Once we are ready to start porting the behavior from the blueprint to the code, we can go ahead and open up the editor again. So starting off here in the camera edge, we don't really have any variables. The two variables we see here are the components that we have. So we don't have to make any variables in our header file. Really, we don't need to make any other functions either. We have our onComponent hit event here, so we'll copy this over. Really, we don't have any other functions or things we need to make either. We do have the onComponent hit event, which we do need to set up, and that is for the camera edge visualizer in particular. So we need to make two components starting off, which is our box component and our camera edge visualizer component. So you'll see box here is the box collision and camera edge visualizer is the static mesh component. So going back to the code, we can go ahead and transfer these. First of all is our two components. So let's go ahead and start out putting them in protected for now. So we're going to make the box collision component, and this was literally called box. So we're going to make class box collision uBox collision, and we'll make this a pointer. We'll just call it box collision component, and actually, sorry, let's call this box uBox collision component pointer, box collision component. And we're going to make the static mesh component. This is going to be class uStatic mesh component pointer, static mesh component. Now these were called the camera edge visualizers, which we will get to. And a lot of times components are capitalized in Unreal. I'm actually not going to do that. Now we have our component classes, and we can go to our basecameraEdge.cpp and go to our constructor where we set the default values for variables, set up components. And first thing we're going to do is set up our collision component. So we have box collision component. And we're going to create default sub object, which is going to actually make this component exist on the actor. Because right now it's just an empty component that we've made, or rather an empty pointer, so it's a null pointer. But we want to actually assign it to something. So create default sub object, and it's going to be our uBox collision component class. Then we need the name of it that we want to use. So usually it's set up in Unreal like this, text. And for the text, we'll call it box because that's what it was called in the blueprint. You could also call it box collision, whatever. Box is fine, so we'll do that. Now we need to attach this to the root component. So box collision component, set up attachment, and we can use root component. Now we need to include this type. So in the header file, we forward declared the uBox collision component, so we didn't actually have to include it up top. That's what this class section does. But in the CPP file, we are going to want to include it. So we can come up to the top, include box collision component. And this might not be the right name. And so I cut away for a second to look at the documentation, and I'm calling it wrong. It is box component. So we need to include component / box component.h. And instead of box collision component, it's uBox component. So apologies for that. We can keep the name as box collision component, but when we refer to the type, it is just uBox component. So there we go. Now you'll see this is working. We're attaching the box collision to the root component. And now the other one is going to be our static mesh component. So static mesh component equals create default subobject. This is going to be U static mesh component. We're going to do the same thing here. So we want to put text and we want to name it. Now, it was actually called Camera Edge Visualizer in the engine. If you want to use that, the same name from the blueprint, you could do that. I'll leave it to make things simple, but you can also rename it here if you want. And then we want to set it up on the root component as well. So static mesh component, setup attachment, root component. So now our components have been set up. We just need to get that other function, the on component hit. So to set up on component hit, it's a little bit different than on actor hit. We're not going to actually override that function itself. We're going to make a new function that's going to get called when the box collider collides with something. So we can make a new function here called when the box collision component collides with another object. Void hit box collision, something like that. Now if we go into the base camera edge and go into begin play, we can actually bind the delegate for the on component hit to our function that we made. So specifically it was on the box collision component. So we can grab box collision component on component hit and it's add dynamic, and we want to call the function on this object, which is our base camera edge, and the function we want to call is going to be the new one that we made, which is hit box collision. But we're going to have to add a few variables to make this actually work, because this function doesn't have all the parameters that the on component hit does. So if we go back to the base camera edge.h and update this function, we can add a u primitive component pointer hit component, I believe it's usually referred to as. So this is the component that we hit. Then there's an actor pointer for hit actor. I think they call it other actor in the on component hit, so we'll follow that other actor. Then we have another u primitive component pointer, which is going to be the other component that was hit. And we have an f vector for normal impulse and a const f hit result reference hit. Now, of course, I like to use this style, so I'm going to change them. So now we've set this up to have the same parameters that on component hit does. So if we go back to base camera edge, you'll see that it's not erroring anymore because it can pass all of those parameters into this function. So now we just have to make sure this function gets called properly. So we have void hit box collision, and we're going to need to copy all of our parameters in here and paste them in. And then we can do whatever it is in here that we want to do. And make sure we do a base camera edge, colon. There we go. Now building this will fail because in our on component hit, we need to add an ampersand to the function call. We need the class type, which is a base camera edge. And the reason for this is because we can actually call other functions from other classes as well, so we have to be explicit here. Also, in basecamera.cpp, I want to scroll down and fix something from the previous episode. We had this function, is team1 character on left, that we ported from the blueprints into the code. In here, we were returning false if the team1 character was on the right, not on the left, and then otherwise we were returning true. But we had no other return statements if we didn't go into these if statements, which was actually giving an error. So we can fix this by simply removing the return true that was inside of here and return true at the end of the function. That way, as long as we don't return false here, we will return true. That accounts for all possible paths. Alright, so the editor is back open. We're going to go into our camera edge, and we're going to fill out this logic in our hitbox collision function. So the first thing we're doing is taking the other actor parameter that's passed into the function and casting it to our specific character type, which is the fighter template character. So to do that, we can come into this function, and we should check for validity. So if other actor. So if there is another actor, then we can say if auto base character equals, and we're going to take other actor, and we want to cast this object, so we're going to put it in parentheses, and cast it to our fighter template character. So cast a fighter template character, just like that. And to actually use this in here, we're going to need to include this class. So include fighter template character.h. And here we will be able to cast that type, put that parenthesis in there. And now if we come back in here, if it does succeed, we're checking the combo state of the fighter template character to see if it's equal to launched. So basically if the character was launched in the air. Then putting it inside of this branch just means we're checking it in an if statement. So this is pretty simple. We can simply do if base character, and we want to get the combo state from this. Now I don't have a getter for it, so we just check combo state, and we check if it's equal to e combo state : e underscore launched. Now we can't actually get this parameter because it is private or protected, and the camera edge is not an appropriate class to grab that variable. So we have a few options. We could move it to the public scope, or we could make a getter for this. So I have some getters at the bottom of this file. I scroll all the way down. We have some getters here. I'll add a new one today. So we can get the character's combo state. And if we want, actually, let's specify, let's keep it like this so we know we're referring to the enum. And we're going to return e combo state. It's going to be called get combo state. And we could define this right in the header if we wanted to. But either way, I'll do it like my other getter. So now I want to scroll down to my get character class function and make it right up here. So e combo state, a fighter template character, : get combo state. And we want to return combo state. So this will allow us to access the combo state from another class. So when we try to do this right here, instead of just getting combo state, we'll call get combo state. Make it that function call, and there we go. Now, if this is true, so if we go inside the if statement, we're also checking to see if the character is facing right. Now, if the character is facing right, we're launching them a certain way, and if they're not, we're launching them a different way. Basically just determining the direction based off of that. So we're going to have another if statement and check to see if the base character is facing right, which we also don't have. And we're going to put this with an else statement here, because if we are facing right, we're going to do one thing. If we're not, we're going to do another. So let's go back into fighter template character, go back down to our getters, and I will put it here at the top. Get the character's facing right value. And now we can say, ooh, get is facing right. And we can go into our CPP, scroll down to our functions. I'm going to put mine here. Stay consistent bool. A fighter template character, : get is facing right. And we're going to return is facing right. Now we can go back into base camera edge. So we want to change this to get is facing right function. Just like that. And I have a function in this series called custom launch character, which does a little bit of extra work, which I'm going to use. If you just want to use regular launch character, you don't have custom, that's perfectly fine. But this is going to take in basically all the same stuff that launch character does. I'm just going to call this function instead. We're calling it on the character, which is the target. Then for the velocity, we have 800 on the Y, 100 on the Z. And we override the X, Y, and the Z with this. So if we go back into here, we can make an F vector. And we can pass in 0.0F. 800.0f and 100.0f. And then we can pass in true and true. And then we're going to copy this and paste it in the else, but this time we're going to make this value -800. We can turn these numbers into variables, this 800 and 100, which we'll do at the end here. So regardless of what happens, if we go to true or false, then we meet up again and we set the combo state to be wall bounced. So after this, we're going to do base character, set combo state, and we're going to pass in e combo state, : e underscore wall bounce. Problem is we don't have a set combo state function, so we can go into our fighter template character, go down here below get combo state, say set the character's combo state, and we can do void set combo state. It is going to take in a e combo state, and then we can go into the CPP one more time. And below where we are getting it, we want to set it. So void a fighter template character : set combo state. And we're taking that e combo state. So in here, we're going to set combo state equal to state that was passed into the function. So now we have a setter. And if we come to base camera edge, we now can call this function, which will allow us to do that. Then lastly, we were calling a function ignore player-to-player collision that is in the fighter template character, passing in should ignore of true. So I can come right below this, base character, ignore player-to-player collision, passing in true. And now we have successfully ported this over. We don't actually need this if other actor. So other actor will be able to be cast even if it's null, and then it will fail this if statement. So we don't actually need to check for validity here like we do in a lot of cases. So to clean this up a little bit, I'm going to do that just so it looks a little bit nicer for us. But now we have successfully ported everything from the camera edge into the code. And anyway, guys, that's all I got for you today. Thank you so much for watching. If you enjoyed watching this episode and following along and porting the camera edges from blueprints to code, then please subscribe. It does more for myself and the channel than anything else you can do, and I really, really appreciate that. I want to give a huge shout out to all my supporters, my YouTube membership, Patreon, Discord supporters. You guys are amazing, and I appreciate you so much. Thank you. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community and I would be happy to help you out. So thank you so much for watching. I'm Shawnthebro and I'll see you in the next one. Goodbye, guys.